Hey guys, so we are going to jump to Unit 3, Day 4 notes. I'm going to skip the proofs, which is the hard stuff for you guys, and move on to stuff that hopefully you'll be able to easily understand. So I have the notes right in front of me. We're going to talk about finding sides and angles of isosceles and equilateral triangles. So first we need a little bit of a reminder of what an equilateral triangle and what an isosceles triangle are. So remember, an equilateral triangle has 3 equal sides and 3 equal angles. So it looks something like this in the picture. You're going to label it with little dash marks for the congruent sides and little half circles for the congruent angles. So that's what an equilateral triangle looks like. Also, it's important to know that all angles in an equilateral triangle make 60 degrees because remember, 3 angles at 60 degrees makes 180, and that's what all triangles make. Then we've got a picture of an isosceles triangle. An isosceles triangle has 2 equal sides and 2 equal angles. So we're going to put a little dash on the 2 equal sides and a little half circle on the 2 equal angles. So those are your pictures of what an isosceles and an equilateral triangle look like. So this is what you're going to see in Alex. In Alex, you're going to see that they're going to give you a picture of a triangle, either an equilateral or an isosceles, and you'll have to either find a side length or find an angle measure. So for the first one, you have to find the side length of AB. So the side length of AB is what we're trying to find right here. That's this side right here. Well, remember, this is an equilateral triangle, which means all angles are the same and all sides are the same. So if one of the sides is 4, then that means every other side is 4. So there's your answer. In the next example, it's asking you to find an angle measure, the measure of angle F. Well, this is a picture of an isosceles triangle because it has 2 sides the same. And one of the angles is a 100-degree angle. So if I want to find out what the other 2 are, I know that they are equal because they're an isosceles triangle, and together all the angles make 180. So I'm going to take my 180 and minus 100, and you have 80 degrees, and then cut that in half. And if I cut that in half, I now have that each angle must be 40 degrees. Same with the next example. You have another picture of an isosceles triangle, and you're asked to find angle X. But look at your picture a little closely. You have 2 sides of the same, therefore you have 2 angles the same. So if angle Y is 40 degrees, then angle W is also 40 degrees. And 40 and 40 make 80. So how much is left when we have the open angle that we have to find? 100 degrees. So that's your simple one there. Moving on to the next page, it gets a little bit harder. On the next page, it gets a little bit harder. Now they're going to give you a picture of an isosceles triangle, and you're going to have to find X and then find the degree of each measure of the angle. So this is a little bit more work. So in your picture of an isosceles triangle, remember that sides and angles that are equal are always across from one another. So you'll see in this picture of an isosceles triangle that the angles are opposite one another and they're opposite of the sides. So you need to remember that in the following picture. So in the example that we have an isosceles triangle, and remember the angles that are across from the side are also equal. So since the angles that are marked in this picture are the ones across from the sides, we know that they are equal. So we're going to set up an equation. So back to your algebra roots. 4x plus 21 equals 5x plus 11. And then we got to get our variables onto one side. So we're going to minus 4x and minus 4x. And we're going to that gets rid of it on the left side. And we have 21 equals x plus 11. And now we're going to get rid of the numbers or move the numbers onto the other side. So we have minus 11, minus 11. And so now x is equal to 10. Remember, though, that they don't want you to find x. They want you to find the measure of every angle. So this equation or this problem takes a lot of work, because now what I have to do is I have to plug x back in. So if I plug it back into this one, then I've got 4 times 10, which is 40, plus 21, which is 61 degrees. And since they're equal, I also know that this one is 61 degrees. But to find this last angle, angle K, I'm going to have to take the two 61 degrees, add them together, and I get 122 degrees. And to figure out what's left over, remember they all equal 180. So we're going to take 180 and subtract 122. And we get what? 8. 68, right? Yeah. So the last angle is 68 degrees. All right, so let's try another one of those examples. So then in the next example, they're going to give you another picture of an isosceles triangle, but it's a little bit different. So in this picture, we have the two markings on the triangle are right here and here. And remember, the angles across from those are the ones that are equal. So we got to look across from that, and I'm saying that this angle must be equal to this angle. So angle F is equal to angle E. Okay? So angle F is 5x plus 17, according to this. So that is also what angle E is. So this is also what angle E is. And then they give us what angle G is. So therefore, we're going to put them all together and set up a giant equation where it equals 180 degrees. So we have 5x plus 17 plus 5x plus 17 plus angle G, 4x plus 20, is equal to 180. So combine like terms. We've got 5x plus 5x plus 4x. So that's 14x. And then we've got 17 plus 17 plus 20. So that is 54 is equal to 180. So we're going to minus the 54 from both sides. And we've got 14x is equal to 180 minus 54, which is 126. We're going to divide. I'll move it down a little bit. We're going to divide by 14 on both sides. And x is 9. So remember, we have to plug that back in for all of our angles. So if I plug it back in, then angle F is equal to 5 times 9 plus 17. So 5 times 9 is 45 plus 17, which is 62 degrees. And remember, angle F is the same as angle E. Angle F is the same as angle E, so angle E is also 62 degrees. And we'll write that down, which is equal to angle E. Okay, and also if those two equal 62 degrees, then we can find the last one by plugging in 9. Angle G is equal to 4 times 9 plus 20. And 4 times 9 is 36 plus another 20, which is 56 degrees. So we've got 56, 62, and 62. So this problem definitely takes up most of your time. So be aware of that. Take a look at my notes. Take a look at what you might have written down at the same time. Okay? Follow along and go back in the video so that you can hopefully get some help with this problem. If you have any questions, you can ask me. Now, the last set of notes is pretty easy, so we've got that. So pretty much with the last set of notes, you're just going to have to pick one of the definitions for each of the pictures that they give you in ALEKS. And the important thing here is to only pick one. So in ALEKS, they're going to give you multiple choices, and they're going to say select how many options you think the picture applies to, or the definitions that you get to choose from, and you're only going to pick one. Okay? So this is pretty much a little easy topic for you, hopefully. So I'm going to tell you what each of these pictures represent, and then you can use this when you're working on the topic in ALEKS. So in the first one, it's a picture of a triangle with a line drawn down the center with a right angle marking, and then two of these little tick marks, which means that they are congruent. So because those little tick marks are there, and because we have a right angle, this is called a perpendicular bisector, because it makes a perpendicular line on the bottom, and it bisects or cuts the bottom into two equal parts. Now notice what the next picture has. The next picture has two markings. They are angle markings, and they mean that those two angles are equal. So when we have angles equal, then we call this an angle bisector. Okay? So that's a picture of an angle bisector. The next one is a picture of two segments that are equal. So you would think that this would be called a segment bisector, following in the trend. But this has a particular name that you might not remember. But when two segments are cut into equal parts, or when a segment in a triangle is cut into equal parts, that is called a median. And then the last one is another name that you might know, but pretty much a segment is drawn down the middle of G, and it forms a right angle. And instead of this being a perpendicular bisector like the top one, this one is called an altitude. So you can use these definitions when you are in ALEKS and you forget what they are. So you can either write these down or you can refer back to the video. It's totally up to you. So that's all the notes that I have for you guys. Hopefully this helps, and maybe you can get some of the work done in ALEKS. Let me know if you have any questions. Kate?